Hi, I'm Matthias Loibl, a senior software engineer at Polar Signals. Today I want to talk to you about second-day operations for SLOs. For the last 7 years I've worked with Prometheus, and I'm actually a Prometheus, Thanos, Parquet and Pyrra maintainer, and for more than 4 of these years I have worked with SLOs and Prometheus. So let's start off by imagining this person being on call that you can see in the picture. And they receive Slack messages with alerts, or they get tickets into a ticketing system or GitHub issues. And the most critical alerts they will actually receive on their phone. They might be woken up in the middle of the night to handle those incidents. Thankfully, this person has previously attended SLOconf and they've already are active users of SLOs, or they have read on the topic elsewhere, they have read the SRE books, etc. So the team they work within actually monitors how many requests are getting into the system and how many of those are successful in errors. And if the error rate, the burn rate is too high in comparison to what the SLO's objective is, they will alert on those. After every quarter, this team the person works within, they will meet to do a retrospective, and they will talk about what went wrong or what could have gotten better and what went well. And they will also talk about the goals or the objectives for the next quarter. And yeah, they might do so using OKRs. So OKRs, what are those? OKRs are objective and key results. So you can see on the left-hand side, you have objective, which is a qualitative statement of something you want to achieve as a team or as an organization. And it should be something significant and concrete, and it should be a clearly defined goal. On the other side, you have key results, and those are quantitative outcomes. And for every objective, you want to have 3 to 5 key results. Those key results should be something that is measurable between something like 0 and 100%, or between some arbitrary number that you set as your kind of like goal or result that you want to achieve. And then you will always compare how you're doing against that number. So you might be thinking, well, maybe this is totally exactly like SLOs and SLIs, right? Not so fast. OKRs aren't SLOs, but they can be somewhat related, and we'll talk about that. So how do we get from OKRs to SLOs, right? That's the overall question. So an organization might start with the objective, an OKR objective of where the organization should go. They will define some user journeys or like some expectation customers have, etc. As objectives, and then they will start looking at what the key results are, and they will define these measurable key results, and yeah, we'll take a look at what to measure for the objective, right? They won't, however, talk about services yet or APIs, etc. And this is kind of eventually where, once you have OKRs defined, you can then use those to derive SLOs from. They might inform, the OKRs might inform what the SLOs should look like, right? So you can break down those results into SLOs, and then you can figure out which service is used for achieving the overall OKR objective, what you need to instrument, what metrics you might need to add, etc. All of that. Let's talk about an example. So at Polar Signals, we are building Pyrra, an open source project for continuous profiling, which is inspired by Prometheus. And on the top right-hand side, you can see this merge button. And this merge button was always there since we started the project, but we knew that eventually we wanted to get rid of this merge button because it was kind of a manual process, and it was something that we had put in place as a safeguard to super heavy queries, right? And we wanted to work on that, and we wanted to make progress. So this screenshot is from last year's summer. And today, as you can see, we don't see a merge button anymore. When you click on search, the metrics graph will render and show the overall, in this case, CPU samples per second. And then at the bottom, you see the icicle graph merged over the entire T of the timeframes that is selected. So right now it's 5 minutes, but this might be an hour or even like 6 hours or days. And we, again, as I said, we want to get rid of the merge button. So our objective was that users get query results faster. And we looked at the key results, and the key result was like, well, 1 hour merge queries should 50% of the time answer within 30 seconds. And we actually kind of started with a super, super high goal of 30 seconds because most of the queries back then didn't even answer for 1 hour merge queries at all. So we set something super high for the latency. But then in Q4, we gotten better with the storage, and over time, we actually got more and more results back. So the P50 latency went actually below 30 seconds. So for Q4, we had updated the key result for 15 seconds. And then this last quarter, we had the same, and we actually went below 7 seconds. And yeah, you can imagine what the next quarters will look like. So we are making progress, and by the time we were below 10 seconds roughly, we said, okay, this is good enough, so that like whenever somebody clicks on the search button, it will just instantly merge the entire time frame into an icicle graph. And for the cloud service, we actually had something where we then alerted on that. That's where we put in place the SLOs. So the open source project, we have some demo examples with SLOs, but for the cloud product, we actually do something super similar, and we use those OKRs to inform what the SLOs will look like. And as you can see, every quarter we basically updated this like OKR label. We updated the 7 seconds from the previous numbers down to what we actually use, and then this less equal label also of the histogram was updated to reflect that change. Now, to visualize and to kind of manage those SLOs with Prometheus, we actually use Pyrra. And Prometheus in the background is monitoring and scraping the services, getting the metrics and storing those metrics over time in the time series database. And then Pyrra is an open source project that kind of sits on top of Prometheus, and it will actually generate alerts and load them into Prometheus that are multi-burn rate alerts that are well defined for that services SLO. And yeah, Prometheus does the heavy lifting of alerting us. And as you can see, we've also added those labels from the configuration. Those will show up, and you can see we've already filtered for OKR equals Q1, and all those labels show up in the OKRs we see here. Yeah, and then we look at this specific SLO, you can see the same label shows up, but we get some more details on the SLO and how much error budget there's left, etc. All right, let's summarize. So OKRs can inform SLOs, but they aren't like a 101 mapping where you can say, okay, if I have an SLO, if I have an OKR, I instantly know what the SLO is going to look like. You can iterate on the OKRs and then obviously also iterate on the SLOs. Once the OKRs change, SLO might change, and you want to reflect those changes. And the best thing is you can get started today. All of the things I've shown are open source software projects, and you can download them today and get started. That's it. Thank you for listening. I'm Matthias Loibl again. You can find more resources linked on the slides. Also check out the SLO DLC thing by Noble9, which is a different approach with iterating on SLOs, and you can find the Parka and Pyrra projects linked from here. All right, that's it. Thank you and have a great day.